Good day viewers, you are welcome. How to solve these nice algebraic equations? We are given 2 power x plus x equals 37. By this time, you might have guessed what the answer is. But let's see how we can solve these beautiful equations. Actually, we can solve this with different methods, and the most common method people use is the Lambert W functions. But let's do something different this morning. We are going to solve this using another method apart from the Lambert functions, and we're interested to get only the real solutions, and let's get into it. Let's consider the solution first. Here we have 2 power x. Suppose if I let 2 power of x equals t, then when I introduce logarithm on both sides, let's say I introduce log of base 2 here, we have log base 2, then 2 power of x equals log t base 2. And for the whole of this, log 2 power x base 2, this becomes x because log of the same base equals 1, and everything equals log t base 2. And coming back to the questions, we have 2 power x plus x equals 37. And by replacing 2 power x with t, then plus we have x here, which x has becomes log t base 2 equals 37. Then by making log t base 2 the subject, we are going to transfer t to other side. So this becomes 37 minus t. Then here we have log of t base 2 equals 37 minus t. Suppose we have, note that, let's say we have the logarithm of b base a equals x. This is the same thing as b equals a power of x. And by applying this rule to this, we are going to have this becomes t equals 2 power of 37 minus t. And by this property as well, if any number raised to power of difference between two numbers, we are going to separate them as we apply the law of indices, which it becomes 2 power of 37 then multiply by 2 power of minus t. And getting to this stage, we have 2 power of minus t. This is negative on the base of 2. We can still apply another rule here, another rule of indices. If you have a raised to power of minus n, this equals 1 over a raised to power of n. Then we try to substitute, we apply it to this as the value of t here, t equals 2 power of 37 multiplied by 1 over 2 power of t. Then by cross multiplying, we try to multiply 2 power of t with t, and this becomes t multiplied by 2 power t equals 2 power of 37. Then we have, and if this is what we have here, we have t multiplied by 2 power t equals 37. As 37 here, suppose I write this as t multiplied by 2 power t equals 37. We can break 37 as the sum of, let's say we have 32 plus 5. 32 plus 5, it gives us 37. And also, we note again that, let's say we have a raised to power of m plus n. This is the same thing as a power m multiplied by a power of n. This is another rule of indices. Applying it to this, we have t multiplied by 2 power of t equals 2 power of 32 multiplied by 2 power of 5. And 2 power 5, it means multiplying 2 in 5 times. Then we have t multiplied by 2 power of t equals 2 power of 32 multiplied by 32. Then, so this one, it means multiplication. By trying to compare this based on their coefficient, or we can just write it properly as, if this is t multiplied by 2 power t, so this also the same thing as 32 multiplied by 2 power of 32. And comparing this, we have this as t and this is 32. You can just say t equals 32, or again, we are going to have 2 power of t equals 2 power of 32. And we cancel the same base here. We still have our t here equals 32. So we get the same thing for the value of t here by comparing either t, or we compare 2 power of t with the corresponding side here. As we are going to recall that, and we recall from what we let 2 power of x equals t. Yeah, because we need x, not t. We just get t first before we can get x. As t equals 32, replacing it, we have 2 power x equals 32. Then we need the value of x here. We are going to rewrite 32 as 2 power of 5. Because 2 power of 5 here, it gives us 32. As we have the same base here, we are going to let the power equals to each other. Because these two must be the same. And for this one to be the same, it means that the value of x here must be equals 5. That is only when these two can be equal. So x equals to 5 satisfy this problem. As when we try and verify for if x equals, given that 2 power x plus x equals 37. So let's try and replace x with 5. So we have 2 power of 5 here. This gives us 32 plus, and x is 5. So 32 plus 5, this gives us 37. So which shows that x equals to 5 is the solution to this problem based on real. Thanks for watching. If you come far to this stage and you get something, please do well to subscribe, turn on the notification bell, and drop another method we can use to solve this easier than this or harder than this. See you in the next class. Never stop learning. Bye bye.